I was complete with the functions for last week. I'll continue with the object-oriented programming, and then today marks the end of the basics of Kotlin. If you have any question, you can ask. Then I'll jump into the Android. So while we learn the Android, we'll continue to use the Kotlin. Then you gain mastery. So today I'm using the IntelliJ IDE, the community version. The last time I used the playground, but today I'm using the IDE. I don't often use it because I write all my codes in the Android Studio. If you don't have it, it's no issue. Once you have internet, you can continue using the Play Store till you resolve your issue with it. Object-oriented programming is a very broad topic and it's popular in almost every programming language, be it Java, Python, PHP, JavaScript. They all have the concept of object-oriented programming, or OOP for short. But what exactly is OOP? So the object-oriented programming is just a way to mimic real world objects. So you see in a real world we have an object like a car. A car has properties like color. We have different type of cars in SUV, the trucks. We have different kind of cars. Yeah, they have color, they have weight, they have brand. So car from BMW, car from VW, car from Opel, etc. We are just trying to model our code in that manner. We are trying to model our code in that manner. We are trying to create a mental model of our problem that we are solving in code as an object. So since objects are made up of two main things, the first is properties. Every object have property. Car have a property of color, brand, name, etc. When it comes to animate objects like animals, a dog, for example, has a color. They have breed. And another thing with objects is their functions. So all objects behave or they act. They act. So the action they perform translates to functions or method in code. And the properties they have translates to variables, or we still call them properties in code. So when you are given a task, for example, let's say shapes. Let's say you are writing a code, especially game developers, they deal with shapes a lot. So they deal with shapes a lot. And shape is the main word. Inside a shape, you can have an example like a triangle. You can have a triangle, you can have a square, etc. And these triangles and this thing has properties that distinguish one from the other. So this object-oriented programming concept is very broad, but we'll touch on the basics and then I'll just mention one or two. But the meaning, because when it comes to Android development, most of these classes, we call something classes, which are the like a recipe or the blueprint prints for creating this thing objects in code. So those classes we have inbuilt classes that are provided to us by the Android community or by the Android Google, that are provided to us by Google, that you can extend, you can rely on to develop your app. So we use classes, this object-oriented concepts a lot when it comes to Android development. So when it comes to object-oriented programming, we have two main concepts, which is properties and then actions that the object performs. So let's see how we can create a class in Kotlin. So to create a class, let's create a class called car. You use the class keyword, then the name of the class, and then the classes based on convention. We use capital letter to start the first word of a class. So it's not like a variable. It's not like a variable where we do something like var, then we say h, where we start with small letter. We don't do that when it comes to class. You start the first word with capital letter. It's a convention just to create a standard. It doesn't really mean anything. And then you bring the open and close bracket. So this is where you specify the properties and then the functions that the class can have. So usually a class is like a recipe. When you have a recipe, you out of that recipe you can make a lot of food. You can come out with plenty food. Let's say recipe for making cake. Once you have that recipe, you can produce the cake as many times as you can. That's how a class is. With a class, it's like a mode or a pattern that when you use, you can be able to create more objects out of it. So anytime you want to create an object, you first need a class. It's like you want to prepare food. You need a menu. You need a recipe. You need a recipe in order to prepare food. You don't just jump and then mix ingredients anyhow and then whatever come out, you start injecting it into your stomach. Now, you first use the menu. Literally in our homes, they don't use menu because we've been taught how to prepare those food way back from when we were young. But we still follow it anyways. So this is our recipe. So to create the recipe or the class, we use the class keyword, then the name of the class, and then the open and close curly brackets. So inside the curly brackets, you specify your properties. So the properties are just variable. When you use variables inside a class, it is called property. Okay, so you create your property. Let's say for a car, we have the color. Which other property? We have brand. Okay, so this is now. So this is how you create a property. But in this is like using the Java style. In Kotlin, you specify the properties through the constructor. So we have something called constructor. Constructors are like some inbuilt. Yes, please. The class is being recorded. So constructors are inbuilt mechanism that classes use to create objects. So anytime you create your class, let's say a recipe, and you want to create a food or some meal out of that recipe, it is the constructor that actually performs the action for you. So when you come to the class, constructor will create an instance and set up all the properties and then make the functions that will create inside the class available to you. When you create a class and you are declaring the variables in this way, this is Java style, like this is the old style of doing it. It is all right, but it is not idiomatic and then it is not that kind of flexible. So we pass the properties right here through another bracket, like the way we create functions. So you can specify your variable here as color. So let me copy paste here because it's colliding with the existing one. So it works. Here too, you can set and give it an initial value. But with this, you can remove the initial value. So this is how we create class in Kotlin. So when you use the class keyword, you pass the name of your class and then set the properties within the curly bracket. And then inside the curly bracket, you can perform your actions here. So let's say, what else? So when you create a function, so the how is it called? The actions or the behaviors of the car translates to functions. So you use function to create the actions for the car. And when you use a function to create the actions, they are called method. So a function in a class is called method. So I can also create a function called drive. So you can drive a car. So we can have another function called, let me say, stop function. When you call it, it stops the car. This class has two properties. So now let's see how we can create an instance of this class. Like we can create objects from this class. As in we can create food or meal from this recipe. So to create a car, let's create our first, let me call it first car. So you can specify the type, which is car. So if you specify the type, you can pass in the initial value. So the first car will have. So here too, you can specify the name argument. So we have color. So we've created the first meal. We've created the first meal from our recipe, or we say the first object from our class. So like Kotlin usually do, it is able to infer the type of this variable or this object based on the value we supply to it. So as you can see, this part of the code is disabled. So if you hover over it, it says explicitly given type is redundant here, so you can remove it. So with the value supply, Kotlin can determine the type of this car object. So now you can access these properties on the car. You can print something like first car dot the year. So when we run it, we have, yeah. So we have 2020, that's the year. So to access the properties on that object, you use the notation. So you bring the name of the object. So this is an object and this is the class. So as I said, the class is like a recipe. Out of it, you can prepare a lot of food, and the food or the meal will be of that type. Which type? Which is car type. It's like when you have recipe for cake, you can't use the same recipe to prepare jollof. They are not the same. You can only use the same recipe for cake to prepare a lot of cake, but you can't use cake recipe to prepare rice. That's how it is. So I can create more instance of this car object. Let's say another car called car 2. So here I'll pass different value. So this time this car, the color will be red, and then the brand. So this is for first car. This is for the first car. So when I run the two, you see that they'll have different year. Yeah, so this is for our first car, and then this is for the second car. So we are able to use this car recipe or blueprint to create more cars, and that's what the cars industry do. You see maybe BM E90. You see a lot of people in town driving that E90. They don't all the time go back to the drawing board to think about how to create that car again. Nah, they just think about it once and then they make that model available. Anytime you want to make more of it or replicate it, you just use the same pattern and you recreate one. So out of this class, we are able to make a lot of cars. You can continue to declare, hey, I think here I'm pretty the same year. Sorry. Car 2. You guys didn't see it. Hello. Are you following?
Yes, you saw it. I was trying to tell you, but you saw it sometime.
Okay, okay. So let me run it
The cash should be capital letter.
over here.
Oh, it does not matter.
No, it's small. See, this is it. It's small
Okay,
letter. This is
okay.
a variable. This,
Oh, all right, all
yeah,
right.
I name it car 2. It is different from this car.
Oh,
This
I've
is,
seen it.
okay, this is the
All
class.
right, thanks.
Yeah, sure. So this is how you create a class in Kotlin. Let's see how we can access the method in the class. So we are able to use the properties. We call the year property, etc. We can also call the start. I think we have start and then we have drive. Start is like igniting the car, and then so let me name this method start rather, and then create another one called drive. So let's call that method. You can do like this. Let's say for the first car, we want to start the first car. You just type the name of the object and then dot. If you click on the dot, you see the properties. Those are the properties, the brand, this brand color, and then you can also see the method on it. So this is the stop, the start, and then the drive. So I can use the start. So if I run it right now, yeah. So we have start driving a car. So I can put this whole thing in a print statement. Okay, I'm getting an error here. First car. I just call because it's a function. I'm supposed to call it on the next line so that it's already having the print statement in it. Yeah. So let me test it again. So you can see sometimes we'll get an error. So first car starting. When you see an error, don't panic. it's part of programming. You face issues in your day-to-day problem solving. Sometimes you can be late for class and you'll be rushing. For all you know, maybe you left money or your phone in the house. You have to rush back for it. You can't leave it because how will you board a car to school? So it's the same when it comes to programming. You face issue here and there, but don't panic. You can ask. That's why it's good to have a mentor or someone in your same field that you can easily reach out to and say, "Oh, I'm facing this problem. How can you help?" Then ChatGPT too is available. Stack Overflow still exists. It's not dead. It can help you out. So you face issues. Don't panic. That's one thing. Okay, so this is our classes. So we have another concept called inheritance. So it's like so inheritance is like family traits. So think about your family. You might inherit certain traits from your parents, like their eye color or hair color. In programming, inheritance allows one class to inherit from like you can inherit the properties and functions in one class from another class. This way, you don't have to write the same code again if it's already defined in a parent class. So we have this car. I think let me use the animal car for this. So this time around, I'll copy the code and paste so that we can move faster. So I'm creating a new class. You can see I'm outside the main function before I create the class, and I use the class in the main function. So pay attention to that. So I'm creating a new class called animal class. So I use the same keyword class and then the name of the class, and I pass the name property to the class. And I have a function within it called eat. And when you call that function, it uses the name you pass to it and say, let's say dog is eating. But there's a new keyword here called open. For now, this class cannot be inherited. Another class cannot rely on this car class to use it. In order for you to inform Kotlin that you want another class to be able to use this class, you have to use the open keyword. So this informs the Kotlin system that this class can be inherited. The properties and then the methods within it can be inherited to another class. So we have the class called animal, and then I'll create another class called dog that inherits from the animal class. A dog is a type of animal. So over here, every animal has a name, but every animal does not bark. Every animal eats. Yeah, almost every animal eats, but not all bark. Some make sound, but not barking. So when you create another class called dog, which is a type of animal, you can inherit the animal class so that you don't have to specify the eating method again. If no, you will have to copy this code and then paste here so that when you create an instance of a dog, you can call both the barking and then the eating. But with this inheritance, so to inherit from a parent class, so this one becomes the parent class and this is the child class. So to inherit from a parent class, you use the colon. Yeah, this is colon. You use the colon and then the name of the class, the parent class. And then if that class takes an argument, you have to pass that property to the parent class. So this is what is happening. This one takes the property and then send it to the parent. Takes the property and then send it to the parent. That's what's happening here. So let's see an example. Let's create an example of a dog called Buddy. So we create a dog called my dog and then we pass in the name Buddy. Now let's print. So here too, we did not specify the type, but we just pass it through this. And this one takes one argument, so we did not bother to use the named argument. So you can also use name is equal to this to specify the parameter, or you can remove it. Since it's one, we don't have issue. But if you have a lot of argument, then specifying the name of the argument helps you to avoid confusion and also does not require that if color should start. So for example, here I can copy this and put at the end. It will work all right. You see, there's no error. It doesn't need to follow a particular order if you are using the name argument. Okay, so but since here is only one, you don't have to worry about it. So I have the object my dog, and then I can call the method eat. So as you can see, this eat method was in the animal. But since we inherit, we use this column to inherit it. We are able to call it on the dog object. You see, the object we created here is of type dog. It's not animal. It's of type dog. But we are able to call the eat method that was found in the animal class. So this is how inheritance works. It makes those parent class properties and then functions or method available to you. So we can also call my dog back. So we are able to say body is eating and then barking at the same time. So any questions so far?
Yeah, sorry, please. I didn't get the concept of inheriting clearly. Can you just reiterate it again, please?
When I talk about inheritance, think about like your family. So with
Okay.
inheritance, when you were born, maybe your mom was taller than your dad, and then as you were born, you became very tall. We know that you picked that trait from your mom.
Yeah.
So it's the same concept. Since your mom has those properties, he's able to pass those properties down to you. Your mom is your parent, right? So in the code to the class from which you are inheriting or deriving those properties become your parent. So for this dog and animal, we have the animal class. So properties and then behaviors that are common to all animals can be placed in this animal class.
Okay.
Things that are common to all animals will be placed in this animal class. So as you can see, almost all animals eat, but not all bark. Cat doesn't bark. Chicken or cock doesn't bark. They make different sounds, but they all eat. So properties that are common on your entities, you place them in the bigger or the parent class, and then from that, if you create another class for like a special group of that animal that needs the major properties, then you can use this column and then you bring the name of the name of the parent class, and if that class also needs some properties, you can pass it to it.
Okay, okay, I get it now.
Okay,
Okay.
so even this animal class can be broken down into several parts. Like this is just the animal class. We can have for like mammals, we can have for like aquatic animal, we can have for like domestic animal, we can have for wild animals, etc. So I was giving the example of shapes. So when it comes to shape, that's the bigger class of all shapes. Within the shape, we have like triangle, we have square, we have rectangle, we have circle. So the properties that are common to these shapes, you can declare them inside the shape class. So let me work on the shape class for you once again. We have a class called shape. So from this shape class, I think every shape has a name. Every shape, I think you can calculate the area. I'll create a method called find area. So I'll just print calculating area. Okay, so every shape, whether square, rectangle, or those things, you can find the area. So that's a common property. So to make this one, okay, so let me create a triangle class first. So we have another class called triangle. Okay, when it comes to triangle, what's unique thing can you calculate on okay, let's see. I'll create a function called I'll create a function called find function called number of size. I'll just say number of size. Okay, so number of size, it has to return an integer since it's telling us the number of size. So I'll just use return 30. Okay, for this one, I'll just use return 30. So I want to find the area of a triangle. Since a triangle is a shape, I don't have to come in inside your code, copy this code and bring it here in order to find the area. No, you can just bring the column and then inherit the shape class. But for now, we are getting an error that says what? This type has a constructor and thus must be initialized. Okay, so let's provide the initial value. Since it has a constructor, So we have to initialize this. So I can supply this thing name string, and then I'll pass the name here. Okay. Although I've done that, it's still throwing an error. It said this type is final, so it cannot be inherited. And the IDE is suggesting a solution that make it open. So when you click on open, it will put the open keyword in front of the class keyword, and with that, it is able to like the error is gone. So now we can inherit that property. So like I said, you don't have to copy this and put in this again. So now with this inheritance, you have this function available in this class. So when I come here and I create a variable called try, I'll just say triangle is equal to, let me see, my triangle is equal to triangle, and I'll pass one name. I'm just passing this. So now we have an object of this triangle. With that object, I can say I think my triangle now. I'll say triangle dot. So now you can see we have find area. It has the property of find area, and then it has the method find area. Although we've not created that method inside of the triangle, we are able to access. You see, there's no find area method here. It is rather in the shape, but we are able to call it on this object. The object will be created from the triangle, not shape. We've never created an instance of shape, but we are able to access how, because we use this to extend it. Please, is it clear?
Yes, it is. Thank you.
Sure.
To an extent, I think the semicolon. No, let me like rephrase. Let me like I really understand what you're saying.
Okay.
Now, after declaring a class,
Yeah.
now the first code line there, where you have the class, you go up to the where you have the class triangle, you're like declaring what is the property that is very common to that class of shape. When you use the semicolon,
Please, can you hear me?
there, it's like you're getting an you're extending the properties of shape. Can you hear me?
Yes, please. Yes, please. I can hear you. Go ahead. Yes, please. Yes,
So,
please.
okay. So, go up a little bit. Go up a little. But the reason why we could find that find area, that property of find area, why dealing with the triangle was because it was initially declared. It wasn't declared in shape, right?
Yeah.
But because it was declared in my triangle, but because of the semicolon which we use to extend shape towards the triangle. Don't mind the way I'm explaining it. I'm just trying to like really grasp. So that's the reason why we could call that find area property. Right?
Yeah. It's because of this colon
Yes,
and
this is now.
and then the property and sorry, the parent. So it's like we are drawing a relationship between these classes we are creating now. So it's like you all are in a class and I'm your instructor. I invited your parents over, but I don't know them one on one. So maybe I'll call for assembly and I'll say, I don't know your name. Is it Light or something? So go to everybody. Yeah, everybody should go to his or her parent. You see that you move to your parent. I also another student will also move to their parent, and through that, I'll draw the relationship that okay, this is your mom, this is your dad. So this is like a relationship we are drawing. I'm saying this triangle belongs to the shape. I'm saying the dog belongs to the animal class. And to do that, to achieve that belong, we use the colon, and then the name of the parent. And here, it is not all the time that you pass the name. But in this case, the parent has a property called name. So here you have to specify that name to it before it to be certified. So you can also set a default value. If you set a default value, then it won't complain anymore. Is it okay now?
I want to ask something. Yes, okay, I want to ask something. I don't know, it's not sticky, but let me just ask. Normally inheritance is like from parent to child, but I guess this is more like, can we call this parent to child now, or like child to parent? I don't know how this is going.
So which one, when it comes to this, which one is your parent? Which one is the child?
I know the parent is the shape,
Yeah.
right?
So
The
the
child is the child.
yeah. So the child is the triangle, and the shape is the parent. And then here the animal is the parent, and then the dog is the child. Yeah, because a dog is a kind of animal, but not all animals are dogs. So this guy belongs to the animal kingdom. Yeah. So we can have a class like vehicle, a class called vehicle, and vehicle includes all moving objects. So out of that moving objects, you will have like SUV, different kind of cars. So you can group most of those the common property into the vehicle class. Then out of that, you extend the car, the lorry, the trucks, and all those things from the vehicle class. Okay. Okay. So these are the two major ones we'll be using often. We have another one to call the interface. Yeah, we have another one called interface that we often use. So let me highlight on that one. Then we'll go into our Android Studio and start something over there. So an interface is like a contract or a list of rules that a class must follow. It defines a behavior, i.e., functions that a class needs to implement, but it does not provide the actual implementation itself. So think of an interface like a menu in a restaurant. The menu lists all the dishes. So the menu lists all the dishes, but it does not tell you how each dish is prepared. That's up to the chef. In this case, the class in programming terms. So unlike we have abstract classes, a class can implement multiple interface. So if you want to create a class, so usually me I use interface when I'm making some network calls. So when we get to the advanced level, I don't know if we'll get there. Then making network call from Android application, we use an external library like REST-Profi. So that library helps you to make a REST API call to the backend. So during that period, you use an interface. Like the library specified that you should use an interface. So you create an interface and then later implement the actual implementation of those interface. So to create an interface in Kotlin, you use the interface keyword. So there's a keyword called interface, and then you can create some. Let me copy this template so that we. So I've created two classes called one drivable, and then the second one called flyable. So these are like classes, but you don't specify the actual implementation. So if you see in this class, the dog class, we created a function called back, and we brought the implementation. That's the body of the function. We specify what should be done anytime when this function is called. But when it comes to interface, you don't specify the body. You only declare it this way. So whichever class implements or extends. Okay, so another word for extending or inheriting is implementation. So we have extending, implementing, or inheriting. So any class that inherits from this interface has to implement or give it a body, but we don't do the body in the interface class. So I'll create two classes from this. So this one, you just have to keep it in mind when we are dealing with interface actually, then you see the actual implementation. So we have this class. I think it's crashing with the one we have at the top, but I'll fix it soon. So we have a car class. Let me do it, or I touch this one so I'll get comments. So let me comment out this. I've created a new class called car that implements. So this one also implements or inherits from the drivable class. So this class has, so as you can see, we have override because, so this is how it works. If you create a class. Okay, you create a class, and then oh sorry, you bring here that you are about to inherit from that interface called drivable. So, so when you do this, you see you'll be getting an error because this interface will force you to give the actual body for this function. So if you inherit from an interface and the interface has a function in it, it will force you to implement that function to give it a body. That's why we are having this error. So if you hover over it, you will see class car is not abstract and does not implement abstract member, blah blah blah. At the end of the day, what it's saying is that you should implement or give an implementation to this function over here. So when you hover over it, the IDE can help you resolve that issue. So just click OK. So you can see our error is gone. I think this is my class, so you don't have to bring that. So you can see, so as you inherit, you see that it brought the body of the listing and then print place a to do. So I can print. So I provide actual implementation or I provide a body for the function. So it is the same thing in this place we've inherited from the two interfaces. So if you want to inherit from multiple interface, you use comma to separate them. So over here we were dealing with just one. If you want to do two, then you use the comma to separate them. And we know plane can drive, as in they walk on the floor for some time before they take off into the air. So plane has these two interfaces, which allows you to, as in plane is driving on a runway and then plane is flying. So we have these two things. So if I should copy and then remove all this, you see we'll be getting an error and it's telling us that same thing, abstract, blah blah blah. And when you hover over it, yes, it forces you to implement those two methods. You see. So interface is like a contract. Anytime you engage with it, you have to fulfill your side of the bargain. So any question? Please, any question?
So, I want to ask something.
Okay.
So more like this interface now, we are not like passing the property. They're not, you already have your own English property.
I
But
already
so
have.
what I'm asking that,
Please come again. You said we already having.
like, it doesn't have its own English property because I don't really understand why we're using override. Like, override is, I don't know, maybe
Yeah.
it's more like you don't want that specific property to affect.
Oh yeah. So that's how it works. It's just a keyword to say we are overriding it. Because this when the function was created. So here we want to give an actual implementation to it. So to do that, you supply. I'll beat you. So to do that, we use the override keyword. It's just a decoration to indicate. The thing is, if you create a function call, okay, so if you create this function right now, the only way you can differentiate between the two is when this key declaration is here. So it's just a decorative word to show that you've implemented or like the thing was in the parent. So this is like the parent class. It was from the parent class, and you are giving it your interpretation over here. So you are overriding it. You are giving it your own interpretation. So these are the main things I'll talk about. When it comes to object oriented, is a big topic, and the four main pillars of object oriented. Sorry. we have some four pillars when it comes to object-oriented programming. The first one is encapsulation. So you can read on it. This is also another big word to saying hiding the complicated parts and then showing just what is necessary to the user. For example, with a car, when you're in your car, you don't really care how the engine works or the fuel bends. All you need is holding your steering wheel and then your legs on the paddles. That's all you care about. Even if you are a mechanic, I don't think when you are driving you think about the way the engine bends or does something. Yeah, I know people have those things that they can determine that, oh, my car, there's something wrong with my car based on the sound and all those things. But normal, that's not what you do. Your focus is on the ride. You don't care about the engine and all those stuff. So that's encapsulation. So, for example, we have a bank. So I can have like a bank account. With a bank account, you don't really care about. For a bank account, we have something like the balance. You don't want people to know about the balance, but you are able to make a deposit into it. That's an example of encapsulation. You are hiding the initial like the main or things that you think should be secret or should be hidden from other entities. You use the encapsulation to achieve that. And in programming, we use things like one is this inheritance, and then another one too is the private. We have keywords like private. So when you append private before this backing. Oh no, sorry. Let me put it here. Since this is the parent class, if you put the keyword private before this it method, no other class can access it. Although this dog, this dog class have inherited from this animal, it will not be able to access this it method at all because you've made it private. So it is only private to just the animal class. Nobody can access it. So if we go to the dog instance we created here, you can see we are having an error. So this error is from the car because I commented this. That's what is happening. But I'm not explaining that part. I mean this part. You can see we are having an error here. If you hover over it, let's see the message. It said cannot access it. It is invisible. Oh sorry, cannot access it. It is invisible. Into bracket private in super type in dog. So make it public. So you can make it public. When you make it public, it means it becomes public information. But when you bring this um, private keyword to it, nobody can access this it outside this animal class. So that's what we call encapsulation. So we have for the keyword, we have public, we have I think protected and private. So you use these things to control access to data and then certain actions. Okay, so take note of encapsulation. That's one of the pillars of object-oriented programming. And the second one is inheritance. That one we've discussed it. And then we have another one called polymorphism. Polymorphism. Think of a TV remote that works with different brands of TV. Even though the remote stays the same, it behaves differently depending on which TV is controlling. So in programming, polymorphism lets you create objects from different classes the same way. For example, so we have let's say animal class open, and then we have open sound, and then the dog that stems from, and then you override it, and then okay. So for the polymorphism, it's just a way to let one thing behaves in different way. So like the TV example I gave, TV remote example I gave earlier. When you are using, let's say those universal remote, you see that when you are controlling some TVs, sometimes some of the keys that the TV does not respond to some of the keys, but when you are using different TV, it will respond. That's how it is. So it behaves differently based on the TV or the object you are controlling. So this animal class can have a method called uh, sound, which is the sound animals make. So this one too will mark it open. So you mark this function open. So animal makes a sound. That's the function. So inside the dog class, you can override that same function. So normal, when you call the animal, you create an instance. That's my dog at the top here. You create an instance. Um, my dog. Okay, let me turn this back to sound method, which represents sounds animals make. And we've marked it as open. So over here, when you create an instance of this dog, this is it. When you create an instance of this dog, we can call my dog the sound. You can call the sound this thing, the sound function. And when you run it, you will see this sound, animal make sound. But this same function can be override here. So we have okay. So as you can see, we have when you click on when you type sound, you are able to override the message the sound function. Then you can provide your own implementation here. So you can do some like although animal makes sound, dogs bite, barks. You see. So this is your own implementation. Let me comment this one and try to run the app and let's see. So we have animal make sound and then dogs bite. Okay, so this one prints the two. Let's create animal. So we have today's dog and then you have animal sound. So if we run this, it creates another animal, but it's acting as dog. See, so we treat the dog object as animal, but when we call the sound function, it behaves like a dog and
Sorry,
barks. Yeah,
your screen is no longer showing.
is it visible?
Yes, it is. Thank you.
So because of this inheritance and then polymorphism, we are able to create an animal which is of type this, but the instance is a dog. And when we call this animal, it prints dog is barking. Let me run it. So you see, it will print dog bite barks. So it's just a way of the same thing behaving based on different implementation that you give it. But in the parent, it has animals make sound, but in the dog we gave it a new this thing called dogs bite. So I think you can remove this. So this one gave it dog bite back. The dogs back. So if you bring that super, so I think the super means it should provide the super class. So it is called parent class, super class, all those things. There are terms you meet more often. So it's called super class, and this is subtype or something. Is it so? If it has that super keyword, super dot. So if you call the super, it means that you want the one from here, but without the super, then it will print just your new implementation. So now this function, this sound is no longer producing this one, although we inherited it from the animal class. So it's your function behaving differently based on something. So if I create a cat class right now, if I over inherit from the animal class, then I can overwrite it and say cat meow. Yeah. So that's something small about polymorphism. And then I think polymorphism, and then we have the abstraction. So abstraction too is like the encapsulation. That one too is another way of hiding the complexity of your objects. Yeah, so these are the four things you need to keep in mind. Let me write them here. So we have inheritance. So first we talked about inheritance, and then we talk about polymorphism. And then we have abstraction. Okay, abstraction. And then we have mm, is there a rest spelling of the encapsulation? Yeah. So when it comes to object-oriented programming, OOP, these are the key things you need to keep in mind. Okay. So any question? Any question?
My question is more like do you have like
Can you also
okay, so my
hear?
question is more like do you have a material you can read up on?
Yeah. Okay. I'll share.
Like it's a conversation we can read up on or yes.
Okay. I'll share one in a group.
Okay, thank you.
Welcome. Okay. So I'm moving on to Android Studio. Let me do introduction course. From next week, we'll start writing or creating our applications. Okay, so this is Android Studio, our IDE for creating applications. So, like the way we have the IDE for writing Kotlin code and other stuff, when it comes to building Android native Android application, we have a dedicated software for that called Android Studio. So this is how it looks on Mac. If you create, if you just install it fresh, there will be there will be, I think this thing, the new create new stuff and some beginning getting started information will be here. But if you've ever created a project, then the main screen will have the list of the projects you've created. So I've worked on several apps. So as you can see, they will be shown here. And then these are projects. So if you want to customize the interface, my current one is in dark mode. So I can change it to the light mode. Yeah, as you can see, this is the light mode. You can change the font size. Yeah, and then you can add plugin. So if you, for example, we use it the same IDE to create Flutter applications. So if you want to create Flutter, you have to install that and then Flutter plugin. So I create Flutter application as well. So I have it installed here. ChatGPT plugin. So they are just third-party tools that you can use to um, facilitate your work. And then if you want to learn more, you can also come here that you get sample codes and some tutorial on it. We have settings. Those ones we will dive in later. So I think let me decrease the font score. Some part of it is gone. I think 14 is okay. Okay. Okay, I'll keep it at the 18. Okay, so let me switch it back to the dark mode. I like the dark mode. So when you come to your project, you have the list of projects here. That's if you've ever created a project. And then from there, if you've installed a Flutter framework or plugin, you have the option to create Flutter app. But I'm not talking about Flutter in this class. Okay. So then you have this new project. So this is where you create your new projects. So when you click on this new project button, it will bring another window. So from this window, as you can see, we use so it brings you templates. You can start with absolutely nothing. That's when you'll be writing everything by yourself from scratch. This is absolutely nothing. And then we have starter templates that you can quickly jump with. So if you want to create an app with some button at the bottom there that you can use, this is we call it floating button action. Floating action button. Sorry, floating action button. You can use this one. We have bottom navigation. So if you want bottom navigation, you can choose this. And we have two options now. So as you can see, we can use C++ to also create application in Android. So not just Kotlin and Java. You can use C++. So we have markets for C++ as well. So Android Studio is providing that. So now we have two options between XML and then Compose. So currently I'll teach you XML. If you want to proceed further, I'll add the Compose to it. But starting, I'll teach you the XML so that you know the pain, some pain that are there, and then the new API that is offered to us. So yeah, so we have the template for this is for phone and tablets. This is for watches.
Sorry, you said a new API. How do you call the name, sir?
Compose, compose, compose. That's
All right, I got it. I got it.
sure. Yeah. Okay. So we have compose. So if you want to create compose application, so that one you write everything in Kotlin. You write everything using Kotlin. You don't write XML. So that one you select this one. But if for now we are using the XML, so you choose one of these.
Sorry, the XML and the compose, are they for interfaces?
Yeah, they are just for interfaces. The view, like the graphic we are interacting with, is just a view.
Okay,
The
okay.
backend logic is still the same.
Right.
It's still written in either Java or this thing, but the UI, as in what the user clicks, like this button, the toolbar, this icon,
Okay.
and all those things, we use either Compose or XML. So you have two options now. So we have the
So
template.
is it that we need to learn the two, or we just choose one?
Yeah, Compose is the future.
Okay.
Yeah, going forward, you need to know Compose. So it is the future. It's a new thing, and they are pushing it. Like Google have accepted it. They are pushing it so hard.
All right.
So that's the new thing if you want to learn. Just that
All right.
this thing has been in the system for very long, and the XML has been there almost 20 years now. So there are still code in the system. Big companies don't just switch onto a new technology when it comes. They still, once it's working, they don't touch it. It is these startups, and then when they are creating new app, then they can try the compose. So when you learn the XML, you still have your chances there. Like job is still there for you. And compose is still new, so once a while you might face some issue with compose. If you know your view, you can come back to your view and kill your thing and go. Yeah, so it is not just about phone. We have this Apple Watch, we have Android Watch from Samsung and all those things. So we use this Android to create it. So this health application and all those stuff, you can create them from here. So some TVs are Android TV. So we have the View, and then we have the Compose version here. So this is the logo for Compose. And then some cars. This uh, is it Tesla cars and all those stuff. The interface, not just the Tesla car. Most of these smart cars like the BM and all those stuff have the Range Rovers, the Benz. They have their interface is made with Android. Those Android interfaces like the Google Map and all those things in these small cars. They are made from this place. So it's not just mobile app. Yeah, for the mobile phone, not just for the mobile phone. You can go into TV where the watches and then cars as well. That's when you are an engineer, you know these companies you work with. You can send your service there as well. Okay. So let me go back and then show you something. So this open. So if you have an Android application, let's say I'm sharing this project to you on WhatsApp and you download it onto your machine and you want to open it in Android Studio, how do you open it? So you come to your project, the app interface and click on open. So when you click on this open, it takes you into your project system. Then you can select the folder. So let's say here I have Android Studio. Then I have all the projects here. So I'll just click on them and then I'll open it. I don't know. I think this is my TikTok app. Let me try open it. So boom. So as you can see, it will open the project for you. I'll cancel it for now and then I'll go back to. Yeah, so I'll go back to it. So I'll create a new project. So to create a new project, I'm starting with XML. After this course, if you're interested, I'll teach you the compose. So to create a new project, you select the you select this empty view activity. Select empty view activity. You can also choose this, but this one includes navigation and it's advanced topic. You need to get the basics before you begin with that. So you come here, you specify the name of your project. Specify the name of your project. So let's say our tradition, Hello World. So our application is called Hello World. And then you specify a package. So a package is just a way to group your application folders. So you say inside your project there should be a directory where like every file you create will have this extension so that when you are including a particular file in a project you have to specify this part. In JavaScript we'll say like import. When you are importing you need to specify this part and then the name of the file slash the name of the file. So and this package name also becomes the project ID. So what's this project ID? When you submit your application to the Play Store, it needs to have a unique ID, and this package names becomes your unique ID. So you might, if you go to the Play Store, you have application like say to do application. If you go to your Play Store and you type you type like to do application, you have a lot of options. How come there's no conflict? It is through these application names. This is your ID, so it becomes your company name in reverse order. So my company name is 8-bit technology. So it is comp dot company name dot the app name. So if you have another app called, let's say, to do app, then it will become com company name dot to do app. You can change it to whatever you want. Let's say your name is light, so you can say light dot to do app. Yeah, you can say light dot to do app or your full name dot to do app. It's just an ID. It's unique after all. This is unique. Okay, so this is just the location on your hard drive where you store your project. So you can click here to change it. If you have your machine in front of you, you can be trying these things. And then we have the language. So you know we have Java and then Kotlin for creating application. So people are still using Java. Kotlin 2 is there. So we are learning Kotlin, so we choose Kotlin. And then we have the API version. So you see, we have Android library. We say I'm using Android 8, Android 12, Android 13, and all those things. It is not just a version number or the phone version number. It translates to code. Every version comes with certain support. Like you see, when your phone somebody calls you and you pick up your phone, the phone vibrates. That's a feature. I think like 3 years or 4 years down the lane, that feature was not there. But let's say Android 12, when Android 12 came, it came with that feature. So the version that we normal users say, oh, I'm using Android 8, I'm using Android this thing. It comes with a lot of technology, and this is the version name of those technology. So if you are creating an app, maybe your app will rely on that vibration that I just talked about, and it is in maybe version 9, which corresponds to the technology 28. If you do not choose this 28 and you choose something like 8, and during this 8, that technology was not there. So if you choose the 8 and you need that feature in your application, if you create the app, it will not work. Let me take it again. So this minimal
Yeah,
SD,
take it again, please.
okay. So this minimal SDK specifies the technologies that comes with Android applications. On your phone, if you check your settings about the phone, you see something like, oh, Android 8, Android 10, Android 12, Android 13. Every year, I think twice a year, or yeah, they release Android versions. Likewise, Apple does the same thing. That's why if you go to every year, Apple will tell you, I think now it's Apple 13 or something. For the users, they think it's a number. It is not just a number, it comes with technology. It is not just a number, it is not just a counting we are doing. It's a technology, like the way you build an application and say, oh, this is version 1, the first version, second version. The second version comes with a lot of features than the first version. The third version will have more features than the first and the second version. That's how it works here. So those Apple things we used to chase is not just a number. They have technologies backing it. And I gave the example of uh, your phone. If you're using latest phone recently, if we have a feature on Android that when someone calls you and your phone is on the table, when you comes to pick the phone vibrates. That's one feature. And even back in those days, we don't have touch, as in the touch on phone. There was no touch. So there was nothing like when you are taking a picture, enable flashlights. There was nothing like that. There was no touch. Before touch came in addition to cameras. So if you are building an application and you want to build a touch light application and you chose a version that the torchlight technology was not available in it. After you build your application, if you want to use the torchlight, it will not work. So you need to make sure you know the features you are building, and then you read on some of these versions and see whether the one you are choosing does it have that technology. And aside that, this ones also come with um how is it called? I think let me select it and I say okay. So you see, as we chose this one, Android API 33. I think this is close to the latest, so the 14 is in. So the almost latest is 13. So for the user, he knows that he's having Android 13, but for the technology, is at level 33. So we are speaking two different languages. And see something here. Is it? Yes. Excuse me. So he's saying something here that your app will run on approximately 33% of devices around the world. So aside that, you know, for instance, my phone, I bought my phone, I think 2021, and I'm still using it 3 years. People will not replace their phone unless there's the need to. So if you buy your phone maybe 5 years, 6 years ago, so far as nothing is wrong with it and you don't require some immediate technology, unless maybe you are that type that follows the trend, any every year you replace your phone, you will not change it. So it tells you this is the percentage of people using the Android version 13 worldwide. So if you choose the latest technology or the latest phone, know that it is only some few people around the world that are using it. So 30% of the world is using it. But let me choose lower version. Let me say version 21. See, 99.7% of devices that represent people holding that phone. So if you are target, so there's a trade-off. Are you targeting the technology or you are targeting users? If you want more users for your phone, for example, you are building the application for people in some remote area, and you know people in the remote area, nobody will be using the latest phone. They'll be using some old phone that they were dashed by some family member from the city. So if you go and build application with the latest technology, let's say 13 or 14, look at it, 13% of devices worldwide. But for the lower ones, you have, see, Android 17, you have 100%. It's everywhere, almost all devices. So there are two things here, technology and then customers. Let me say customers. That's business sense, so that you know that these devices also maps to money. Okay. So any question on that? Okay. So over here, I just this is your build system. So anybody that has done programming know about dependency or package manager. So in JavaScript we have like npm. In PHP we have composer. Yeah, I don't know about the other ones. These are the languages I write, so I know about their package manager. So when it comes to Android development, this is our package manager or our build manager and all those things is here. So in that one, so we have two choices. We have the old way using Groovy, and then we have the new way that is using Kotlin. So it's like everything they are pushing Kotlin deep into Android development. So both the build system is about to use Kotlin, the language is Kotlin, the UI is becoming Kotlin. So when you learn Kotlin, you are going to be the future Android developer. So then you hit on finish. Hey, which I chose 17. Okay, I don't mean to choose to use 17 though, but we move. Okay, so when you hit on finish, so it's building, generating the files and all those things for you. Yeah, so it's generating those files for you. So it's generating, as you can see, Gradle is building. So it's creating, instantiating everything for you. So this is Kotlin code. I know some of you can recognize some things here. You can see the extension or inheritance. So this class, we've created a class that inherited from this. And you can see that there is some override here. It means this function is inside the main one and this class overrode it or some, yeah, overrode it. So yeah, you will see a lot of this style of programming. So it's generating it. So we have the two things here. We have the Kotlin. This is the Kotlin file for controlling the logics of the UI. And then this is the XML. So the XML, if you come here, you see this is how XML looks. This is how the XML looks. And then this option toggles between full design. This is graphic mode. So here you drag and drop. It's still building, that's why it's loading. With this button, you drag and drop. It's called design mode. When you hover over it, you see design mode. You drag and drop here. You split it. So we have the drag and drop here, and then your code here. And then so if you drag and drop, you'll be seeing the effects like extra code being added anytime you add something to the drag and drop. And then we have pure code where you can toggle to the code. So here you type your everything. So this is a view for displaying text. So anytime you want to show a text on the screen in Android application, you use this guy.
Sorry, your view. I can't see your screen again, please. Okay, it's back.
Okay. Please, can you see?
Yes.
Okay.
Yeah, it's back.
Okay. Yeah, so it's building. It takes a lot of time. I think it's almost ready. So so you can see here it's building. So it's setting up, run, configure, blah blah blah. So it takes some time. Also based on your the speed of your machine. So I think I'll go to the Kotlin playground. Uh, and then I'll paste the code we wrote today so that you guys can have it. Yeah, so that's the link. You can go there to check it out. So it's ready. So now we have our folder here. So I'll explain it next week because time is fast spent. I'll explain the folder structure. I'll explain the interfaces, how to go about it. And then this is the file for handling the Kotlin code. And this is the UI that we'll be building. So you can build this with Compose. So if you are building with Compose, that one, this file will not exist. Like XML is gone. You write everything inside here. But for now, we are starting from this one. So as you can see, we have this text. So this UI, you see when I click on it, let me click somewhere else. When I click on the text, you see that the code here, this text here will be selected. Let me do it and you see, that side of the code is selected. So you can, this is a split mode. You can use your mouse and drag and drop, or you can type the code, or you can type the code and you are seeing the effect here. Or we can have the complete mode. Let me reset it. So we have the palette here. So I can add a button. So I can add, you can add a button. Yeah. So this is a button. So I just added a button. This is a test. So the palette is here. We have for text, button, widgets, layouts, container, helpers, Google, legacy, and all those things. So you can just pick them from here and drop it onto the canvas. And then you have it. So you come here to run it. I don't want to go through that. I'll do it on next week. So make sure you come to class on time. Today we spent a lot of time, almost 2 hours. So next week, make sure you be on time. Very important. Any questions?